Okay, we are talking about doing absolute value, and graphing step equations. If you are a student in my pre-calc hybrid class, I need a way to see who is really watching the videos when they are assigned. So if you bring me in class tomorrow a quarter, and I said tomorrow, and some of you might be watching this today. If you bring it, if Friday, when we have class, if you bring to me a quarter on Friday, I will have a treat for you. If you do not even have a quarter, you don't actually have to pay me. You can make a quarter out of a piece of paper, anything that kind of looks like a quarter, just to let me know who watched the video and who didn't. So if you actually have a quarter and you hand me a quarter, I'll hand you some candy. If you have a paper quarter or a pretend quarter, I will still hand you candy. So be ready, and if you have a quarter in class, so I know who's watched the video or not on Friday. This is only for my hybrid students. Sorry, other students who are watching this. No special prize for you. I first wanted to go over the challenge questions, and actually this, you guys didn't have this. This is a challenge questions for some of those students who are in my regular class, but I just wanted to review how we go about graphing. So the one I wanted to graph here is f of x equals x squared. How do we graph that f of x equals x squared? One of the ways that's the best way to do this is to actually think, okay, what are some x's and some y's? What are some things that when I square it, I'd get an answer? So 1, 2, 3 is a good one to look at. Also your negatives, -1, -2, -3, and 0 is never a bad option. 1 squared. So here what we're asking you to do is I'd be asking you to take your x and square it, and that's what would go into your y, or also known as your f of x. Okay, so 1 squared, still 1. 2 squared, 4. 3 squared is 9. -1 squared, +1. -2 squared, +4. -3 squared, +9. 0 squared is still 0. So if we graphed all of those points, it would be about here. So this is what the graph, and if you remember from Algebra 2, it is a parabola. It's kind of a curved line. Same idea we're going to do with our absolute value. So absolute value is if it's a negative, it becomes a positive. If it's a positive, it stays positive. So again, 1, 2, 3, 0, -1, 0, -2, -3. Absolute value of a positive 1 stays positive. It's a 1. Absolute value of a positive 2 is 2, 3, 0, 0. Absolute value of a -1 is +1. -2 is +2. -3 is +3. A lot of you could just do this on the graph. So this is what the graph of an absolute value looks like. Absolute value of x is our v. X squared is our curve, and that's going to help us in the next few things that we do. So now, we want to know just what are the rules for graphing an absolute value. Each and every time we could definitely go through and make our table. In this case, a 1. What I would do to solve it is I'd come over here and I'd say, okay, what's the absolute value of 1 plus 1? And then, oh, that should be a plus, not here, not an equal sign. Sorry about that, guys. Plus 5. Absolute value of x plus 1, and then we're going to add 5 to it. So this would be the absolute value technically right here of 2, and then 2 plus the 5 would be 7. For 2, it would be 1 more, it would be 8. If we started with a -1, then we'd have the absolute value of a -1 plus a +1, and then we're adding 5 to it. It turns out to be 0 here plus 5. So this would be 5. Add a -2, let's see what happens. -2 and a +1, and we're adding 5 to it. This would be a -1 in here. Then you take the absolute value of it, you get a +1 plus 5 is 6. So what it looks like, it turns out to be here. 1, 2, 3, 4, 5, 6, 7, 1, 7, 2, 8, -1, 5, -2, 6. And really what it actually will look like is something like this. Now, that's nice, and it's good to know how to do that. But there's another way to think of this. I like to think of this that as a transformation, that this constant being added after the absolute value grouping symbol moves this up or down. In this case, it's going to be up 5. You might remember this from Algebra 2. Inside the grouping symbol, this positive 1 moves it in its opposite inside of grouping symbol, so it's going to move it left 1. So from our usual starting point of 0, 0, we went up 5 and left 1, and that was our new starting. Here, it's like what our coefficient is of the absolute value is our slope. The slope would have been a 1 there because it's like an implied 1. So that's where I've got that my slope was up 1 over 1, up 1 over 1. And so that's why I have a 1-to-1 slope for both sides going one's positive, one's negative. We'll go over another absolute value here in a minute. But this is review. You should have seen absolute values last year in Algebra 2. We'll go over more in a bit. Sorry about that. All right, next thing, we want to do something called a step equation. A lot of times, this is our notation for a step equation. And what a step means is you go to the next lowest integer, okay? So even if we have a fraction or a decimal, you're going to go down to the next integer. So I think the best thing I can show you what this step means, and that's what this notation here means, is step. Now, just so you know, we don't have the ability to do this on most computers. We're getting better about it, but some of the, like in the book, they didn't have it when they were printing the book. So sometimes you're going to see a step look like this, and it kind of looks like 2 brackets. So that's also considered a step equation where you go down to the nearest integer. Technically, this is the one that they should use to show that you go down. If I wanted you to go up, like round up instead of round down, this is the notation that I would use. Okay, that's the one if I wanted to go up, round up. So it's kind of like rounding, round up, round down. Things that we use this in. Used to be with minutes on a cell phone plan, like if you had to pay per minute. If you used 1 minute and 1 second, automatically you use 2 minutes. That's just how they did it. They did this one here in that they automatically rounded up. And I'm going to get rid of this here. Other things we do it now probably with our data plan, with our gigabytes and things like that. Once you go over 1 gigabyte, you're automatically up to the next, you're up to 2. You know, you're automatically going to get charged with that if you're paying per gigabyte, per megabyte, things like that. So there's a lot of things when they're charging you money. If you're in miles, then once you go, 1/10 of a mile, boom, you're charged for the next mile. So a lot of times they like to round up, and there are a lot of situations where we round down to the nearest unit. So it really just depends. A lot of jobs round to the nearest quarter hour. So until you can round up until quarter hour, they're only going to pay you for an hour, even if you work an hour and 15 minutes. Sometimes it's half hour. It just depends on the job. So let's deal with this problem in front of us. Let's see, what would our table look like? So let's give some x's that kind of need to be rounded. Let's say if we had 2.3 or 2.7, or let's go a little higher, 3.9. All right, that one we could round up. How about 4.6? All right, let's talk about where would be our work here. Well, for 2.3, what we're really going to do is go down, we'll round down to the nearest integer, so it would be 2 plus 2. So the answer here would be 4. Okay, then 2.7, again, it would be 2 plus 2. All right, so then that would answer, again, would be 4. 3.9. Now we'd go to 3 plus 2. That answer would be 5. 4.6 would be 4 plus 2, and that answer would be 6. But even if it was like 4.82, that would be the same answer here of 6, because it's going to be 4 plus 2. So let's see, how do you graph that? This is what's really unique, is how you graph it. So that 2.3, here's 2.3 right here. And then we have to go up 4. 1, 2, 3, 4. We're right here, 2.34. And then 2.74, it's right here, right next to it. And then if we had 2.9, so what you end up doing, a good way that we were going to show this, let me show you here, is we're going to go, sorry, 2, 1, 2, 3, 4. We're going to have a closed-in circle here, and then to an open circle is what we do. Okay? So basically, anything from 2.0009 to 2.9999999 it's going to be right here at this level of 4. Same thing, you go one level down for if it's at the level of 1. All right, and it's going to be at the level of 3 here and at the level there. See how I got a pattern going? I know it's kind of hard to see here. This pattern here. So what it is, it's a closed circle on one side and an open circle on the other. Let's talk about why. Well, the closed circle means still at 1, it's still going to be here at 3. But if I jumped up to exactly 2, it wouldn't be here at 3, it'd be here at 4. And so this open circle says not exactly on the line, but everything approaching this little point here. And that's why we have that closed circle and the open circle. And so I think this would be enough to indicate that, okay, this is a pattern and this is how it kind of goes on forever. We don't have to fill up the entire graph. There is no way with step functions. You know, usually with our absolute value functions, we have arrows on the end. There's really no ways to show arrows on the end. So we just kind of keep showing that it kind of goes on forever and we leave it like that. We usually try to fill up, a good amount and we'll be fine. So now let's look at just general rules for translations. All right, so we have groupings and not in the grouping. So usually we have a function. And I'll use absolute values. So we can be inside the absolute values and outside the absolute values. And actually, we usually say minus h here. Sorry, x minus h. All right, and then we have something usually out here. All right, so let's talk about what each one of these does. In absolute value, this acts kind of like a slope. All right, and what it does, it's either considered a vertical stretch or a vertical smash, but for absolute value, it's a lot like slope. And in a step function, it also kind of looks a lot like, or it acts a lot like slope. So here, it's going to be kind of the same way. I'm going to have my little step function here, x minus h. It's the same thing in a step function. That's why we're kind of starting with this. It's the same thing for a step function. So this is a step function. This is an absolute value function. Okay, they're the same there. So the h, this is the left or right translation right here. All right, this tells us how to move left or right. And remember, it's because it's inside the groupings, it's oppositeville. So opposite. So technically, usually we'd say either it goes to the right if it's positive. Here it goes to the left if it's positive, and to the right if it's negative. So that's kind of why we say negative h, because the opposite of whatever h is. This is our constant, and this is going up or down. This tells us whether we're going to go up or down, and it's actual. I'm going to put the word actual here. Actual. So it tells us, do we actually move up? Do we actually move down? Now, same thing for this k, same thing for that h. All right, it's telling us up or down, left or right. So now let's look at some of the examples on that worksheet that I handed out. Here's an example of a step function. And it just was a better way to draw it. I really wanted to see those step functions kind of drawn out. So let's look at an example here. All right, so I want to see if I can get this a little bit bigger, and we'll do the other one here in a minute. All right, there we go. Okay, let's look at the first one. It's an absolute value. The plus 2 tells me from the usual starting point of 0, 0, I'm going to go up 2. This minus 1 in the absolute value says in the usual starting point, I'm going to go right 1. So where my usual starting point is at 0, 0, I'm going up 2 and right 1. Doesn't matter which direction or which order. Heck no, doesn't matter at all. There's no coefficient to my absolute value, so it has a 1-to-1 value, so it's kind of like up 1 over 1 in whatever direction we want. And I have little arrows. Do put those little arrows on the end. You need to start with your mathematical speak. You need to show that, hey, we know that goes on forever. We need to show how smart we are when we're drawing these things. We can't just assume people read our minds. So we need to show that, yeah, we know that goes on forever. Now we have a step equation. Usually that step equation starts here at 0, 0, and it goes over this way. And what we're trying to decide is where do we move that to? That there's nothing on the outside, so it's kind of like plus 0, so not up, not down. But right here, this minus 1, again, is right 1. So what that indicates is I'm going to take this and just move it right 1. okay? And then I can just kind of continue